Good morning and good afternoon to everyone kind of in the global audience. Welcome to the GCP online meetup. My name is Nick Orlov. I am one of the Google Cloud customer engineers based out of the Bay Area. And today we have a super awesome talk that we're jazzed about, talking about the hidden cost of cloud with one of our customers, server density. But first, Yuri, you want to introduce yourself real quick for anyone who's new?
Sure. Hi, folks. Really happy to be here as Nick's co-host. My name is Yuri. I am another customer engineer, and we're coming to you today from the music practice studio here at YouTube, which is always a fun time. Unfortunately, I don't have any opening riffs for you, so I'm sorry for that.
Yeah, well, it'd be much worse if I had any opening riffs. I can't play anything, so you guys are fortunate. Cool, and we also have David Mytton. David, you're with Server Density. You are the CEO and co-founder. Do you want to introduce yourself real quick?
Yeah, that's right. So I'm David. I founded and built the original version of Server Density in 2009, and it is a software as a service performance monitoring product.
Awesome. So just out of curiosity, software as a service monitoring products can be very broad, as can cloud. So would you mind taking maybe a couple minutes and explain like what it is that you guys monitor today, and how you're helping some customers, whether they be cloud or on-premise, and your overall solution?
Sure. So Server Density is primarily an agent-based monitoring product, which means that we have a small piece of software which you install onto your servers. We're completely agnostic about where it might be, although nowadays most of our customers are running in the cloud. But the agent runs, it collects core system stats and sends it back to us so that we can show graphs and we can trigger alerts. You can manage your infrastructure.
Awesome. There's a little bit of a feedback. Do we have a mute on that by chance?
We do.
Okay, cool. Well, when we switch back and forth, we might have to worry about that, but awesome. So David, I really want to thank you for the time. You are based out of the UK, so thank you for joining at 5 p.m. your time. And this is pretty awesome because this is going to be our first international meetup where we're talking across the pond, I guess, as they say. But really, the reason why we reach out to you and the reason why we want to have this meetup is you wrote a phenomenal blog that's called The Hidden Cost of Cloud, that's on Medium. After this, we'll post a link to it so that everyone can read. But I was really hoping that we could spend some time talking about your experience, not only just migrating to Google Cloud, but hopefully an unbiased conversation about what kind of hidden costs you might be referring to, how you tackled those, and then kind of like how you better architect for planning the overall TCO and the overall cost of cloud. So does that sound good to jump into?
Yeah, excellent.
Okay, cool. So maybe first we could talk about what it is you migrated. So I know that you performed this migration, I think it was either late 2016 or early 2017. So maybe you could walk us through your environment that you had to migrate, some of the challenges that you encountered, and how the overall experience went.
Sure. So there's two key problems that have been keeping us working hard on the technical challenges over the last 8 years or so. And the first of those is processing large volumes of incoming data in near as close as possible to real time so that we can trigger alerts for customers. And then the second problem is the storage of large volumes of time series data. And that's what powers the graphs for our customers. So the two use cases are obviously getting notified when something is broken. But once you've got that notification, you need to be able to see what's going on. And so the graphs are pretty important to any kind of monitoring product. Over the years, we've scaled as we've been using the product, and having a stable and high-performance time series database has been a big challenge for us. And we've also had the challenge that at the time that we were scaling, there was no real product that could solve the different scaling challenges, either as an open source product that we would have to run ourselves or as a managed service. And so through the years, we've built our own things internally. And then as services have become available, we've looked at how we can replace them with something that's managed for us, because we're just a small team of engineers. So this brought us at the end of 2016, or kind of in 2016, where we were having problems with our existing time series database. And we built a custom version, a custom system on top of MongoDB. It's a very good general purpose database and has matured over the years and has scaled with us with problems, but problems that we've been able to solve. But we found that we were spending a lot of time building custom code. So time series database is a very specialist application, and we built our own custom version on top of Mongo. So we had to maintain that and build new features and keep it running, but also scaling the hardware side of things. We were hosted on bare metal servers and also across a virtualized environment. And we were spending a lot of money and a lot of time managing what had to be some pretty hefty servers, a lot of SSD storage, a lot of RAM. And we got to the point where we were spending so much time and also cash on the hardware itself that we decided to evaluate the options of replacing the custom-built time series database with either a product or a managed service. So we looked at as many different options as we could. We looked at products from Amazon, Redshift, and also RDS. We also looked at open source, so Cassandra, MySQL, building another custom version on top of that, as many companies have done, rewriting it in the latest version of MongoDB, or as we came to use, we also looked at Google Cloud Bigtable, which was very early on, but was looking promising, particularly because it had an official connector for OpenTSDB, which is an open source time series database. That's what the name is. And that meant that we could offload a lot of the custom feature development to an open source product. So building things like aggregating data, mathematical functions, dealing with retention of data, that was all part of the standard feature set of OpenTSDB. And then the management of the actual data store behind the scenes could be handled by Google as a cloud service, because we could just connect the two together. And so our migration over to Google Cloud started with a single service, OpenTSDB, on top of Google Cloud Bigtable, as the most expensive and most time-consuming service that we had to run. And then as we completed that migration, that went live in just over a year ago, February last year. And having successfully migrated that, running across 2 different cloud environments, we then decided that we would migrate our full workload over to Google Cloud using Container Engine, Compute Engine, and a couple of the different other products as well. So that's a quick run through of the migration story.
No, that's really interesting. And I feel like you're coming from a position that a lot of our customers are trying to grapple with, is they have some custom build applications that are running on premise that they really see some of the value, and that might be their competitive differentiation. But then they also have some kind of more generic applications that really could be run anywhere, and they're trying to identify, hey, do we do a lift and shift, or do we try to rewrite some of our applications? And I know that a lot of our customers can try to grapple with that, but it sounds like you found a really good medium of identifying your strengths, server density strengths, as well as Google strengths, and then just being able to kind of move over what you could, and then optimize everything else in terms of making it cloud native before moving it over. So since you've already kind of crossed this bridge, and since I'm sure some of our viewers are trying to debate if they are ready for that crossing themselves, how about any surprises that you've encountered? And let's keep it unbiased. Maybe positive surprises, but then also maybe some negative surprises that you'd wish you had known before you did the move.
Yeah, absolutely. So I think the one that I've focused in on my blog post is the cost side of things. I think that's really interesting because people often make the comparison between co-location, buying your own hardware, and actually physically racking it through to very, very cheap dedicated servers, all the way to cloud environments. And they're comparable in a way, but really it's not completely appropriate to compare like for like. They're not the same kind of thing. In most cases, if you're just comparing CPU and memory in the cloud to what you could buy hardware, the cloud is always going to be more expensive. You don't really get the cost savings just on the pure dollar value of the resources that you're buying. The savings that you get are in the efficiencies of moving a core workload to the cloud so that you no longer have to manage it. And this comes down to one of the huge advantages of Bigtable in particular, in that we can get scalability, and we know that it's going to cost us a very specific amount of money, and it's completely linear. And we can do that at the click of a button in the Cloud Console or through the API. And that makes the predictability and the management very, very easy. Just comparing to hardware is very difficult to do because all of the added benefits that you get are quite difficult to calculate. So the cost of your team, the software updates, the management behind the scenes, the cost side of things can be difficult. But with that caveat, in that it's not, you can't really compare them directly, there are some interesting features of the cloud which are certainly worth highlighting. And in particular, it's that granularity of cost that you get. So when you buy a dedicated server, or if you buy a physical server and rack it yourself, you know there's probably just going to be a single cost. There's going to be the monthly fee that you're paying for that server, or the one-time fee that you pay for the hardware itself, plus the rack itself. In the cloud, absolutely everything that you use, every single resource is billed individually at precisely the amount that you're paying for. And it seems like an obvious thing, but it is a shift in thinking when you're used to just buying a server and paying a fixed amount every month, regardless of the usage, and whether you're maxing out the server or whether you're not. Whereas in the cloud, you're actually paying precisely for the amount of resources that you're using. And this can be quite difficult to predict. And there are a number of instances where you can get sudden spikes of usage that you just weren't expecting. So for example, if you're looking at your current performance, so buying storage, for example, with cloud disks, you're often buying a certain number of IOPS, the operations. And it's actually quite difficult to measure your current performance to predict exactly how your workload is going to migrate over from physical spinning disks or SSDs over to IOPS in the cloud. And it's that IOPS number is often linked to the storage volume size, at least on Google Cloud, but also the number of CPUs. And that is unusual when you're just buying a dedicated server. We might not even know the number of IOPS that you're purchasing. You just know that with an SSD, it's going to be fast. And that has the side effect of sometimes you're oversizing your instances because you might not need the number of CPUs that you're buying, and you might not need the full volume size that you're buying, but you need to buy a certain number of IOPS. So that's one of the, I suppose, the downsides and the pros and cons of that.
That's really interesting. So I like how you called out kind of these unexpected costs, things that you didn't really anticipate. So you mentioned kind of the over provisioning and how to accurately monitor or identify how much of a resource you actually require. But I'm actually sharing my screen. Let me just jump over into your blog post.
You have to hit the present button, I think, first.
Oh, actually, I did.
Okay, great.
Yeah. So one of the things I wanted to call out was kind of the networking cost. So you mentioned that everything in a cloud is billed and it's billed precisely, which makes sense. But in your blog post, you mentioned that there was a period of time where all of a sudden you saw a huge spike in traffic exiting your network, which ended up costing you some additional funds through Google. What I like is that you and Google were able to work together and identify that it was fraud at the end of the day. However, would you mind taking a second and just explaining your process of kind of identifying that and how you were able to work with Google on getting that resolved?
Yeah, so that's a really interesting example because it's a good example of abuse or an unexpected spike, and you've either got it as actual abuse that someone is misusing your service, or it's a spike of traffic because you were suddenly unexpectedly popular on Reddit or on Twitter or something like that. And they're similar use cases, although probably the second one is the one you want, as opposed to the abuse use case. So in this instance, we had a large spike in traffic to a Firebase website that we host in Firebase just as a static site, the serverdensity.com website itself. And we have a number of budget alerts set up on the different projects within Google Cloud. So we know what our expected budget is going to be for a month, and we have alerts set up so that as we're reaching it, the percentage usage should basically match how far along we are in the month. So 15th of January, thereabout, should be 50% usage. And so we had this sudden spike in our alerts triggered saying that we'd used much more of the monthly budget than we'd been expecting. And digging into the usage graphs, we saw that massive spike that you showed, which was basically the baseline or usage of the website was completely at the bottom of the axis on the graph. So we couldn't even see our actual usage because that massive spike went all the way up. So that was simply a case of opening a ticket with Google support and saying this looks like an unusual traffic spike, not least because it spiked for a couple of days and then went back down again. And working with Google support to get into the logs, it was very, very simple. They just simply said, this looks like abusive traffic and we're going to credit you for it. So I think just actually raising the issues first with Google makes sense to do, but having the budget alerts and the data and the monitoring is important so you can spot these problems.
Yeah, that actually absolutely makes sense. And so you mentioned keeping an eye on the budgeting and monitoring of your existing resources. Would you mind talking for a second about what you're using to do that?
Sure. So just out of the box, there are budget alerts available on Google Cloud, and you can set this up based on dollar amounts and also comparisons to your previous bill. So you can get alerts sent out at different stages throughout the month. And of course, the unlimited flexibility is kind of the whole point of the cloud, but it does mean that you can have denial of service attacks on your credit card now, as opposed to just your application. So it's really important to do that because as far as Google's concerned, this is just your application running, and it's not something that's necessarily proactively monitored by Google. And you may end up hitting your credit card limits and having a problem at the end of the month. So it's important that you do keep an eye on it. So those budget alerts are important, but you can also get the usage data dumped into CSV and also exported into Google's BigQuery product, which is a great way to run analysis on the raw data of what's actually happening. So you can analyze that data obviously by yourself. You can just pass the CSVs or query BigQuery even. You can also use the Data Studio product, which is free as part of the G Suite or Google Cloud as part of the Google tools, which does a decent job, but unfortunately it doesn't support the discounts that are available on Compute Engine. So we found that the automatic sustained usage discounts and the committed usage discounts don't get plotted correctly. And so we're using a third-party tool now called Reoptimize, which basically queries BigQuery and visualizes the data for you. So we can keep an eye on almost real-time. It's not quite real-time data, but it's updated within a couple of hours, up to 24 hours later. So we can keep an eye on everything that's happening in our account. We can drill down into projects, can drill down into the products, and you can also label the resources on the Google side, so you can categorize and group all the different things that you're using and then build reports based on that.
Interesting. Yeah, that makes sense. So in your blog posts, you also called out the need to search for discounts. So you mentioned like your customer usage or committed usage and sustained usage discounts. But would you mind just kind of walking through like what those are and what kind of discounts that you really look for?
Sure. So the sustained usage discounts are, I think, one of the best features of Compute Engine when compared to Amazon's EC2, because you don't have to do anything to get the first level of discounts. Just the fact that you're using Compute Engine throughout the month means that you'll get automatic discounts if you use it for a certain period of time. This is in comparison to Amazon's reserved instances, which are certainly very flexible, but they're so complicated in figuring out how many you need to buy for which instance types and in different regions. And so with the sustained usage discounts, they just apply automatically, and you get a discount as you continue to use a compute engine instance throughout the month. That's really good for usage that you might not be expecting, or as part of a new application, or something that you're just learning about. But once you know what your workload is going to be, and you've got static workloads or workloads that you can predict into the future, then you can buy the committed usage discounts, which gives you even more of a discount. You don't have to pay anything up front, but you do get a commitment. So you have to, it's basically contracting for a period of time, a year or 3 years, I think it is.
So thank you very much for that. I wanted to give some of the folks on our live chat to get their questions answered. And now might be a good time to ask their first question. You've already talked about some of the things you're using in GCP. Obviously, you're running on Compute Engine. You're using quite a Bigtable is obviously a big part of your architecture, and you've already told us that you're using BigQuery for analysis. I realize it may be somewhat difficult to do without a visual aid, but I'm wondering if you can give us, a short summary of what does your architecture in GCP look like, and what products in GCP are you really using?
Yeah, absolutely. So the first product that we started using, as I said, was Bigtable. And when we moved that use case over, we were at the point where we needed to rewrite that project anyway. So we were lucky to be able to spend the time to completely rewrite that from scratch, to use Container Engine, to have it completely containerized, and to use all of the core Google products around it. But with the other parts of the application that we moved over, we decided we wanted to get onto Google as quickly as we could. And so we just lifted them directly from VMs or the bare metal servers, and they run completely as Compute Engine instances. So for many of the systems that we have, we're not getting the full advantage of Google Cloud, in the sense we're not using all of the products that we might use, but that's the direction that we're going. And so the direct lift from the VMs and the bare metal over to the Compute Engine instances was aided because the architecture is a microservices setup. So we have probably 15 or 20 or so different services internally within Server Density that manage different areas of the application. And these are all made available internally through an HTTP API. And our web UI for customers is built on top of that with an authentication layer, as is our public API. So as a Server Density customer, if you're using our API, you're using the same API that our engineers are using internally to manage the different aspects of your account. So things like alert configurations, user profiles, the inventory on your account for the different things, different resources you're monitoring. These are all based around APIs. And the architecture itself is microservices, and the code is mostly Python. So we have load balancers, the Google load balancer products internally. We also use Nginx in a couple of different locations where we're running our own load balancers. But our goal is to move everything over to Google services so that we can containerize everything, and also take advantage of things like the PubSub product, which will be replaced. Our plan is to replace the Kafka and Storm setup we have. So when alert payloads come in, they get processed through Kafka as a queuing system. And then we have a number of different engines which determine whether an alert should be triggered and where the data will go. So part of it will go into the alert engine, part of it will go into Bigtable to be stored for long-term storage. And so the plan is to replace Kafka with PubSub at some point so that we get the full managed service element of it. So the architecture is fairly sophisticated.
Thank you very much. And that actually, I think, starts to answer one of the other questions that we have on the line here, which is, how should folks think about migrating to GCP? Should they be, like you said, trying to get to Google as fast as possible by simply migrating their VMs to Compute Engine? Should they be re-architecting and rewriting their applications, or just containerizing them? And it sounds like the path you chose is some of all of that, right? Some things you migrated as they were, yep. Some things you ended up rewriting or at least containerizing. Based on your experience with that, Do you think you would do anything differently if you were to do it again? Any kind of lessons learned from some of those choices?
I think the underlying principle should be to keep it as simple as possible, because doing a migration to a new provider is a big task and it's going to take a lot of time. And you want to have as few moving parts as possible. So our initial workload was to rewrite and deploy onto Bigtable using all of the Google products around that. But we had no time constraints because this was the first thing we were testing it out. And we connected Google up to our previous environment using a secure VPN. And that has its overheads. There's obviously a bandwidth limit. There's a cost to sending data over the internet. Although it's encrypted, you still have to pay for all the data transfer. And there is a small performance hit because you're moving data over the internet. But really, moving the resources should be done as quickly as you possibly can because of the complexity of doing it. And if you're going to rewrite the entire architecture at the same time, you're going to end up changing so many different things. It's probably going to cause problems.
Excellent. Thank you so much. And then I'll ask you kind of one last question, which I know may not be an easy answer. Perhaps you answered this at the beginning, but if you were to summarize kind of your decision to choose GCP over AWS, what would you say were like really the top two or three things that swayed your decision? And also, I would love to hear personally if there was anything that actually made the decision difficult. If there were some advantages that AWS had that you essentially had to trade off in order to take advantage of the benefits of GCP.
Yeah, so I'll start with the second bit because I think it's probably the most obvious one, which is that AWS is the biggest cloud. And so there are more people who know about AWS. There's more blog posts, there's more resources. They have just a bigger ecosystem, and that can make it a difficult decision to go with what I think is actually a better technology choice because although Google doesn't have as many products, when it comes to comparing the portfolios against AWS, the products that are there, I think, are much better designed and much better implemented. Just the documentation is better, the APIs are better, the interface is better. It's much more consistent. And although some features might be missing, the ones that are there, the ones you actually need to use, and they just work as you'd expect it to. It's clearly been designed from the beginning, which everything, I suppose, has iterations, and AWS has the advantage and also disadvantage of having been around for a very long time. So they've got legacy things that don't work quite so consistently or aren't quite as well designed just because they've been built on later, whereas GCP has the advantage of all of Google's experience being able to go into it from the beginning as a newer product. I think the thing that probably stood out the most for us and where we had to make changes after migrating was around the networking and the cost of that. We moved from an environment where we didn't have to pay for any internal networking at all. All the traffic was completely free across all of the data centers that we had. And when you move to the cloud, whether it's Google or any other cloud provider, they all charge for all of the network usage outside of a single zone. And for the best practices, you have to deploy across multiple zones. And you need to do that just to get the redundancy and reliability, and ideally across multiple regions. But it's really expensive to do that, particularly if you have noisy services internally which you don't control. So something like Kafka, sending the data around different clusters, or even database replication can be very noisy, and you have no real control over that, and it can be a hidden cost that you might not be expecting.
That makes sense. And I know that there's quite a few papers out there that Google's published, that the industry has published on trying to rationalize building for best practices, building for high availability versus kind of building for cost optimization. So that absolutely makes sense. So I know that we're kind of right around the mark. So maybe if I could ask one last question, maybe the $1,000 question is, did you find that it was worth it? Are you glad that you moved over? Any any last thoughts that you want to share on that subject?
Yeah, absolutely. We are very happy now that we've moved on to modern infrastructure. We can let Google deal with some of the things that just have no additional value for us as a competitive differentiator. So scaling the time series database, we don't have to deal with that anymore. our overall cost has been reduced by almost 50%. And that's because we've been able to get significant efficiencies from using a managed service, as opposed to having really beefy hardware, which might have been fun to say you've got hundreds and thousands of gigabytes and terabytes of SSD, but actually wasn't delivering enough value for the business. And we can also say we're on modern infrastructure that is carbon neutral and moving towards being completely renewable, which is great for us as a business. But our engineers love being in an environment that has modern APIs and modern systems and features. And so it's definitely been worth it. And yeah, I highly recommend the move.
Cool. Well, thank you very much for all the feedback. And actually, I do have one more question. Since you are our customer, since you guys at Server Density are having some amazing products that are helping our customers, helping us, etc. Anything in 2018 that we can look forward to from a Server Density perspective? Anything cool coming down the road?
So the main thing is the integrations that we have with various services that people are running. So whether that's software, databases, web servers, anything that you're running in your infrastructure, and also the cloud providers that you might be using. We're building significantly better integrations so we can pull in data from any of your environments and help you visualize and monitor it, and making sure that that is visualized in interesting ways. Graphs are cool, but there are other ways to get the information out of your infrastructure about what's going on, where the problems are, and how to optimize it. So that's what we're building.
Cool. Well, that's fantastic. Well, David, I feel like we could talk to you for so much longer. I just love all the insights that you have. You've walked this path before, so thank you very much for spending the time, especially since it's after hours in the UK right now. But to everyone else who's listening, thank you for watching. Please remember to rate, thumbs up, thumbs down, subscribe. Yeah, hopefully thumbs up. And we'll see you next time. So awesome. Thank you so much, David. Thank you, Yuri. And,
thanks for having me.
Thank you, everyone out there. See you later.